Today in this video, we're going to talk about variables and how they relate to C# and a little bit on how to use them. By the end of this video, you should be able to declare variables. We're going to talk a little bit about type conversions. We're going to discuss scope and why scope is important when it comes to variables. And we're going to get into some arithmetic operators as well. One thing I would like to note before we go any further is a little bit about how to write proper C#. So C# does have a specific format you need to follow when you are writing lines of code. When you think about when we write in English, you end a statement by putting a period, maybe an exclamation point or a question mark at the end of the sentence. But in C# you need to put a semicolon at the end. The semicolon is what tells the computer that you're done with that one particular line of thought. So you can, in theory, split up your lines of C# into multiple lines. But this really isn't good practice. You really should not do it this way. But just be aware that when you are writing lines of code, it is expected that it's going to end in a semicolon. A little bit more before we jump further into variables is that we need to be very conscious about how we use our curly brackets. We put these at the beginning and ends of our classes and methods. So we're kind of using them to in a way, almost chunk different lines of code that belong to either a method or, an overall class. So when you create an open bracket, which is one of these, it also needs a closed one somewhere at the end so that it knows what lines belong to those curly brackets. Any code in between them gets associated with that. So it is a good habit to indent your curly brackets and the lines of code as you start to write things. So for instance, we can see this start method is indented inside of this class. It has its own open and close, just like the class has its own open and close. When we start writing the lines of code for the start method, those are also indented. And we make sure that we do have these nice lines. We're checking those to make sure that these have a pair. So here's our open, it's paired with this one, and this open is paired with this one. So be very careful about your curly brackets. It's very easy to accidentally delete one, especially the closed one, and it can cause some errors in your code. As a little bit of a refresher that we talked about in the last video about what variables are, conceptually, these are the most basic units of programming. We can kind of, we can't quite get any more simpler in programming than a variable. Practically speaking, though, you can kind of think of them as a container, or the example in the last video was think of them kind of like a mailbox. You can create new ones, you can put things inside of them, you can change what's inside of them, and you can look at what's inside of them. So kind of keep that in mind as we're going through that we're going to learn how to do all four of these things today. How to make them, how to assign information to them, how to just look inside of them, and how to change what's inside of them. The first thing we need to kind of learn when we work with variables is how to declare them. And that's the term that we use when we're creating new ones, is we say we're going to declare a variable. And there are 4 rules. These are very important that you need to follow when you're declaring your variables. The first thing is that you first need to tell it what type of data the variable is going to store. And this is very specific. And we're going to go over the different types of data in a couple minutes. But that's the very first thing when you're declaring a variable. What type of data is this variable going to store? The next is you have to give that variable a unique name. Every variable that you make in your program needs to have a different name associated with it so that the computer doesn't get confused and knows exactly what variable you're talking about. And if there is an assigned value, if you are giving that variable data to store, it must match that specified type that you declared first. We can't store numbers inside of letters. We can't store letters inside of numbers and stuff like that. And also, the variable declaration needs to end with a semicolon. Just like I mentioned before, the semicolon is like the period in English where we're completing a thought and telling the computer we're done with this one sentence. So don't forget that semicolon at the end. So let's talk a little bit about data type. When you are declaring a variable, the first thing you need to put in your declaration is the type of data that the variable can store. If you've worked with other languages, you might have worked with something like Python that is not a strongly typed language. And a strongly typed language means that your variable can only store the specified data type. So it's not as loose as something like a Python where you can kind of store almost whatever you want inside a variable. Once you give a variable a data type, it is that data type forever. So make sure you know what kind of information needs to go into there. Some of the common data types that you're going to be working with in this course, the first one, and probably the one you'll be doing the most, is going to be an integer. An integer, if you remember from your math classes, is a whole number. It can be positive or negative. As an example here, we start off with saying int, and that's the terminology we use in C# is just this lowercase int before we do the rest of it. The other data type you might run into is a float, and a float is just a number with a decimal, and that can be positive or negative. We write that out in C# by writing the word float in lowercase letters. Another data type that you might encounter is a character. This might sometimes be called a char. It's just a single character. It can be a number and it can be a symbol as well, but don't think of it in the same way as an integer. Like you can't add two characters together in the same way that you can add two integers together. Think of it as the visual representation of that number, not the actual number. So characters, any character, A, B, C, 5, exclamation point, but it's just one. The other data type you are going to find that you're going to be using a lot is going to be the string. And this is the data type that you use to hold more than one character. It can hold just one character, it can hold no characters, but a string just means that it can hold more than one if necessary. So the word that we use when we're writing out our C# code is we just write in lowercase letters string before we give it a variable name. The other last handy one that we're going to be using a lot in this course is a Boolean. And a Boolean is very simple. A Boolean either stores true or it stores false, and that's all that it stores. So if we need to write a Boolean type data type, we just write the word bool, not Boolean, not the whole word, just bool. We're not going to be working with Unity data types yet this week, but it's something that you really should be aware of because they're very handy and you will eventually need to use them. You can create variables that hold different Unity objects. So the most common being a game object. So if you kind of remember a little bit of what we've been working with, the little bit of Unity we've done, where we can create like an empty game object to store scripts and stuff like that. We can actually have a variable in our script that holds game objects. So that's going to be the most common one that we're going to deal with. So just be aware of that. And you'll see this coming up eventually when we get into more Unity-centric projects. So we would just declare it as a game object data type. As far as naming variables go, this is very important because your variables are going to help you remember what the purpose of that variable is. If you don't know what your variable is meant to do, when you need to call it in your code later on, you're not going to remember what its name is, and you're going to have a difficult time working with it. So make sure that you do give your variable a meaningful name. And it should be named something kind of related to what the variable is going to hold or what it's going to be used for. So for instance, if you were creating variables meant for holding information about people, you might have a integer called age. You could have a float called height. You could have a string called name. You could have a bool for I don't know, like in school or not, like that, or something like that. So true or false, are they in school? So just make sure that you are giving your variables meaningful names. The other important thing to make sure that you understand is all the rules for the actual names, such as you can't put any spaces in your variable name. And your variable name always needs to start with a letter. So we can't have like a variable name, my age. It can't be like 10 my age. That wouldn't work with like the 1 and the 0. It has to start with a letter. And we use something called camel case when it comes to naming our variables. This means that the first letter should be a lowercase, and any other words that are kind of in our variable name are uppercase, and there's no spaces in them. So down here is a good example. So if we did want that integer to hold your age, you could call it my age, with the M being lowercase and the A being uppercase. Same thing if for our string to hold our first name, first would be a lowercase f, name would be an uppercase N, no space. If we wanted to hold high score, again, lowercase h, uppercase S, no space. And if we wanted a bool to hold true or false if we are currently playing a game, is playing, lowercase I, capital P. So as far as assigning values go, you can either assign it a value when you declare it. So we can tell it the data type, the name, and then assign it a value by using the equal sign, giving it the value and ending in our semicolon, or you can just declare it and assign a value later. So if we weren't going to give it a value, we just give it the data type, the name, end it with a semicolon. Later on, then, if we want to set the equal to something, or if we had given it a value but want to change what's being stored in it, like we no longer want 5, we want 10, we do not put that data type, because we've already declared it. We don't need to say it again. If you put the data type in front of it, it's going to think that you are trying to create a new variable, and that's not what we want to do. You're going to get an error because it thinks you're trying to create a new variable with the same name. We just give it the name equal to the new value. So in either instance, this will work. It'll work here where it starts with 5, but then we change it to 10. Or if we did not give it a value yet, this would then be assigned the value of 10. And we can change this as many times as we want. The big key, though, is never to put the data type in front of it after we've declared it. So scope is a really important concept, and I kind of want to take a little bit of a moment to declare some variables inside of some C# code so that we can talk a little bit better about scope. So I'm going to jump over to Visual Studio. And let's say that I have some integers I want to work with. And I'm going to declare those integers in my start method. So I'm going to say like int first num, and I'm going to set that equal to 10. So we declared it, we set it equal to 10. Let's just say then that we need to update this, and we're going to update it once per frame. So we're going to actually, and we're going to talk a little bit more about exactly what start and update mean in the next section, but this is our start method. This is our update method. So we can just think of them as just two separate methods. If I want to change it up here where I declared it, I just say first num is equal to 20. And now first num is set to 20. What if I came down to a separate method down here and I started trying to set first num equal to something else? Notice I am getting an error in my code. That red squiggly line means that we did something wrong. We can ignore these green ones. The green ones aren't a big deal, but the red one means that we have a big problem. So if I hover over this for a second, it says the name first num does not exist in the current context, which is just a bunch of words to say that it doesn't understand what this variable called first num is. Update does not know what first num means, but we declared it right here. Why does it not know what it means down here? And this is where the concept of scope comes in. We declared first num inside of our start method, which means that first num is scoped to start. Since it was declared in start, only start understands what first num means. It means this is its variable. Nobody else knows what first num is. We could come down here and redeclare it, but these are now actually considered two different variables. If we change it to 70 down here, the first num being stored in start stays at 20. They're not talking to each other. This is update's first num. This is start's first num. So we would say that this is locally scoped to the start. So nothing else can talk to it. But what if we do need to use this in multiple methods? Like, hey, we need this here, we need this here. What can we do to solve this? And this is where the concept of, I'm going to pull up my PowerPoint real quick, class scope comes in. So local scope is the variables are only accessible inside the specific block of code it was created in. It was created in start. Only start can look at that variable. A class scoped variable means that it can be accessed anywhere inside of the script. So if we have a variable we know we're going to need everywhere, we want to make sure it's class scoped. And this is very easy to do. We just want to make sure that we are declaring first num, not inside of a method. I'm actually going to cut this out. We want to declare it up here before our methods. So, inside of this class's first curly brace, we can start declaring some variables up here. And since it's outside of these, it's now scoped to the class, which means that start can look at it, update can look at it. We can make other methods that can now see this. So it'll first set it equal to 10 when this script comes live. When the start event happens, which is when the game begins, it'll set it at 20. And then each time a new frame occurs in our game, it's going to keep setting it to 70. So notice we don't have any more errors because now this is scoped to these. So if you ever see that issue I was having, most likely you're having a scope issue, so that you need to make sure that you did declare your variables in the right spot. Did you declare it as a class level scope? Did you declare it inside of your method? With that said though, we don't always want to declare every single variable as a class scoped variable. Your code's going to get really messy, especially when you start working with a lot of variables. Things might accidentally get written. Some stuff just doesn't need to be seen by other methods. So only put stuff out here, only put your variables out here if they really do need to be accessed by a lot of things or held onto and used multiple times in your code. So the more that you do this, the more you kind of get a sense of what should be class scoped and what should just be local scoped. After a little bit about class scoped variables is that we can give it a security setting. And this is only for the class scoped variables. We do not need to do this on those local scoped variables. So security settings, it kind of determines who has access to the variable's information. And there's two settings you're most likely going to be running into: a public variable and a private variable. If we declare a class level variable as public, we'll be able to see that variable inside the Unity editor, and we can change it inside the Unity editor. If we set that variable to private, only that script that the variable was created in has access to that. We can still, it's still fine by accessing it with our other methods and stuff inside of the script, but you can't see that variable in the Unity editor, and we can't make changes to that. And by default, all variables are set to private. You probably, though, might want to just explicitly make sure that some are set to private, some are set to public. It makes it a little bit more legible to see. So for example, you could create a class level public variable called my age again. That was probably fine for public for the Unity editor to know. If you need to store things like bank numbers, though, probably want those to be private. We don't want those to be visible outside of our script. I do want to do a quick demo to show you the difference in how it appears inside of here as well as the Unity editor. So I still have this variable int firstNum. By default, it is set to private. So if I were to save this script and go to my Unity editor, I already have this put on a game object in my scene, so I'll be able to look at my script. And it's right here. And we can see that there's nothing going on with this script because by default, that is a private variable. If I were to come back into my Visual Studio and tell this that this is a public script, I'm sorry, a public integer, and I go back to Unity, we now see we do have access to that integer and we can make changes to it if we want to. We can also keep an eye on what's going on, like if there's nothing in here, but if we were in play and something was happening, we could see that change. In fact, let's do that. We're gonna go over this in a little bit, but I am going to make sure that this just kind of raises up a little bit as we go through. Don't worry too much about this code. We're going to cover that later in the video. But let's just kind of watch it change. So I'm going to start. And we can see the number changing live since it is a public scoped variable. So that's pretty fun. Let's talk a little bit about arithmetic operators. I sort of started to do that a little bit. We can declare our variables now, but we need to be able to do stuff to them. And the basic one that we can kind of work with a little bit is doing arithmetic on our integers. So here are some examples of how we would do the most common ones. So addition, we would need to have our variable and we would say is equal to 5 plus 5. So it's kind of opposite of what you might be used to seeing in like on paper, like if you're in a math class. So usually you would say 5 plus 5 is equal to 10. But since we need to tell it what variable is going to store the result of this, the variable comes first, is equal to, and then your operation after the equal sign. So addition, subtraction, multiplication, we do use the little asterisk to declare that we're doing multiplication, not like an X or anything like that. Division is the slash for division, and modulo, which is the percent kind of looking sign This is a really important operator when it comes to when it comes to integers, where division gives you the answer of how many times does this number go into that number. This gives you what is the remainder after division is done. So 5 divided by 2 is 2 remainder 1. So there are instances where you will want to find that remainder. That is what this is down here. There are some shorthand operators that are really useful. You're going to end up doing a lot of math on what is currently being stored inside of a variable. For instance, if you have my int and you want to take whatever is being stored in there and add 2 to it, you would have to write my int is equal to my int plus 2. That can get, kind of a handful after a while. So another way to write that is we can just say my int plus equals 2. And that just means the same thing. And we can do that with the minus. So just minus equals means the same thing as the integer minus 5. Multiplication and division, those 4 work that way. The last shorthand operators that are really useful is taking whatever is being stored in your integer and raising it by 1. So we could do my int plus 1, we could do my int plus equals 1, but C# has an even quicker way to do that by just taking that variable name, my int, and doing a plus plus. Same thing if we need to decrease whatever is being stored in there by 1. It's just the name of the variable minus minus with obviously that semicolon on the end. And you'll get used to doing your math this way the more that you work with it. The big thing is it's flipped from what you're used to. So variable first is equal to, and then your math operation, not math operation is equal to this. It's always variable first. Strings are one that you're going to be working with a lot. And one of the things that you can do with strings that is going to be really useful for printing information out to the user is being able to concatenate strings together. And we do this by using the plus arithmetic operator on strings. None of the other operators work, it's just the plus one. And this just means that we want to hook together all the strings. So we would start with the first one, and then it would just snap that last one on the end of it. As shown in this example here, if we have a first string storing hello, and notice the space, there is a space on the end here, and a second string, which is equal to world, we can create a variable called final string that is equal to first string plus second string. So hello with this tacked on the end. So it's just one string then. So if we were to print out the results of final string, it would just be the full hello world. So if you remember, I mentioned that variables in C# are strongly typed, which means that they can only store in them the same type of data. But there are going to be instances where you're going to need to store different data types in there. Obviously, you can't make a letter into a number, but what if your string is actually a string of letters in it and you want to store that as an actual number? Or what if you have a number that needs to turn into a string for some kind of reason? What if you have a float? Those are the decimals, and you need to turn it into an integer because you need to do stuff with that. You can't do that right out of the box. What we need to do is something called type conversions. So there are different ways to do type conversions based on what you're trying to turn into what. So I would make sure that you kind of keep this chart, like write it somewhere. You can always Google it in a pinch, but you're going to find that you end up doing a lot of little conversions. So for instance, float to int, if you need to store a float number inside of an int, if you have your int variable, all you need to do is set that equal to int in parentheses and then your float. Like this will convert it and you'll be able to store it in this variable. But do note it does cut the decimal off. It doesn't do any kind of rounding. It just gets rid of it. Int to float, it's called implicit conversion. That means that you don't have to do anything. It just does it automatically. So there's no extra steps. Int to string. This means that you want to put an integer into a string variable. So if you have your string variable here, to turn it to a string, you say it equal to my int is that integer variable dot to string parentheses semicolon. This will take that number and convert it to a string to be stored into here. String to int is one that you have to be careful about, since, you know, a number can always be a string because strings are just like the symbols and everything. But strings can sometimes have symbols in them that are not numbers. They could be letters, they can be, you know, exclamation points and so on. So if you do try to do this on a string that is not made out of numbers, you will get an error. So just be careful. So to do this, we have our variable that's an integer, and we set that equal to int.parse, and then inside the parentheses, you have the string that you need to convert. String to float is almost exactly the same. The only difference is it's float.parse, not int.parse. So this was just a brief overview of variables. Programming is one of those things that you're going to get the most out of actually doing some programming. This was to get you in the correct mindset to be able to open up Visual Studio and start coding. There is a companion video with this where we do some demos, and I would recommend that you move on to that demo one next and work along with me doing some examples of coding with some variables.